All right, so I've got chat open, I've got your faces. Okay, so again, today's normal distributions. Next week is regression analysis. That's what they call bivariate data, where you have a response variable and an explanatory variable. I did that wrong, explanatory response. Then we'll do planning a study. That's where we did the different ways to take surveys, polls. Then we'll do probability, which really needs to be 2 days. We'll see if we can squeeze it into one. Then we'll do the binomials and sampling distributions, and then we'll wrap it up with confidence intervals and significance tests. So we're on track, we're doing good, and we'll see what comes up. And then these pink things are the dates I plan to cover them on, so you'll know what you're missing if you don't make that date. Okay, so normal distribution. So here they show you 4 different normal distributions. I love this graph because it shows you 3 are centered at a z-score of 0 or a mean of 0. And that's the blue, the red, and the yellow. And the green one is centered at a z-score or a mean of -2. So they shifted it back. And then they show you what happens to different sigmas. So if the mean for the blue graph is at 0 and its sigma is 0.2, notice 0.2 is smaller than any of these other numbers. So notice it's narrower and taller because the area under every normal bell curve is supposed to be 1. So if you squeeze these in because your sigma, that's actually the variance. If you squeeze it in because your variance is smaller, then it's going to have to grow taller. And then all of these have different variances. So the bigger the variance, the wider the spread. But remember, everything is an area of 1. So I think you have 12 questions in your myap.collegeboard.org. If this is the wrong address, please somebody send the right one to me to get there. I'm not sure what you guys are typing in, but I want to know exactly what it is so I don't look silly. Your online quiz code is here, and I think I've also posted it in Google Classroom. I'm going to post a video. I can't decide which one I like. This one down here with the Annenberg Learning is gone, unfortunately. I really liked that one, but they are no longer. This one is gone. Crash Course Statistics is there, but it's more about sampling, so I don't think I'm going to send you guys this link. I think I'll send you this link. And then, of course, next time we're going to do regression. Okay, properties of a normal distribution. The center is over 0, a mean of 0. You have 1 sigma, 2 sigmas, 3 sigmas this way, 1 sigmas, 2 sigmas, 3 sigmas this way to the low parts of the tail. And then, of course, it goes on forever, but you're almost down to the bottom when you get to the 3 sigmas. So your properties are it's bell-shaped and symmetric about the center. Your mean, median, and mode should all be right down the middle. The curve never theoretically touches the x-axis. It travels in both directions to infinity and negative infinity. Your area is always 1.0. It is a probability density function. So what they mean is if you start this way, your area to the left is really small, but as you grow this way, the area to the left becomes close to 1. Your standard deviation determines how far spread out it is. So if your standard deviation is a really big number like 100, it's going to be way spread. And if your standard deviation is 1, it's going to be much tighter. Don't forget your empirical. They expect you to know the 68, 95, 99, 7. So if you're 1 standard deviation away from the mean in either direction, you've got 68.2% of the data. We just do 68 in stats. If you're 2 standard deviations away, you've got 95% of the data. And if you're 3 standard deviations away to the left or the right from the mean, you have 99.7 or almost the entire graph. That's why we say anything beyond 3 standard deviations is unusual. And in statistics, we sometimes say beyond 2 because that's the 95% mark. And your z-scores are just your number of standard deviations you are from the mean. So positive z-scores mean you're above the mean, and negative z-scores mean you're below the mean. All right, everybody good? Okay, so let's run some problems here. So let's say we didn't take the chi-squared test because we didn't do it, but let's pretend that on the chi-squared test, the scores were normally distributed with a mean of 85.7 and a standard deviation of 5.4. So if Cedric, who hasn't showed up yet, but I hope he's watching my videos, if he scored a 95, what is her percentile rank? And remember the percentile, I misspelled it, is just the area under the curve to the right of that z-score. So we need to find his z-score, and we won't need his z-score. We know what his actual score is. So for z-scores, the mean would be 0, and we would standardize all these. But since we know the mean and the standard deviation, we're just going to say he's at 95. So we need all of this area back here to get his percentile. In other words, what percent of the class did he perform better than? And we can do it a couple ways. We can go to, if you guys recall when we did normal distributions, we said second VARs, normal CDF. And then we put in the lower bound here, and we always go to theoretical infinity. Well, they've got theoretical infinity. -1 to the 90 times 10 to the 99th power is theoretical infinity. And then the high number here, his number is 95. And then the mean, 85.7. And then the sigma, 5.4. So Cedric's percentile is 95.7 or 0.957 area. So he's in the 96th percentile. In other words, he performed better than 96% of all the people in his class. So that's a percentile. It's also a probability. It's also an area under the curve to the left of the bar. I hope I said left all this time. I hope I haven't been saying right. I get my lefts and rights mixed up all the time. So then let me show you how you do that in Desmos. So I have to open everything up again. So Desmos is really cool because it draws much cooler graphs. So Desmos, oh, my internet's unstable. That might be why. So in Desmos, I can go to the keyboard icon, pull up the functions tab, and do the distributions. So we're doing a normal distribution. So it's going to give me something over here. I can't see past our faces. And I put the mean first. If you don't put anything, it assumes a mean of 0 and a standard deviation of 1. But I know my mean was, I think it was 85.7, and my standard deviation was 5.4. Yeah. And then I have to check this box to find the cumulative probability. So if I check it, it'll let me go from a negative infinity up to 95. And now you can't see this picture, but watch what happens when I click zoom fit. Suddenly, we can see everything. So Cedric's percentile with a score of 95 is 0.957 or the 96th percentile. Okay. So I did it both on the TI-84, kind of boring, and Desmos. Yay, kind of exciting. Okay, any questions on that? I'm going to check the chat room. Nothing? Okay, time to get moving. All right, so let's say that we took the chi-squared test and same mean, same standard deviation, and now we're going to ask, well, how high does Dory have to score in order to reach the 99th percentile? So if you guys recall, kind of gave it away here, knowing what the percentile means is I know this area, I'm looking for her score. So when you're looking for this on the bottom of the curve, not the area inside, you have to do the inverse norm calculation. So when you go to inverse norm, you go to second vars, number 3. They want to know the area. Well, if it's 99th percentile, your area is 0.99. Remember, no area can be greater than 1. And of course, our mean is 85.7. And our standard deviation is 5.4. So this will tell me what her score needs to be for her to be in the 99th percentile. And she'd need to get a 98.26. Okay? All right, and so I tried. I have no idea how you do inverse norm here. I looked, and I didn't have much time because I was trying to get through my Zoom, but there's an inverse something here, inverse CDF, and I haven't figured out how to use it yet, but once I do, I'll let you know. But for now, stick with the inverse norm in second vars, number 3. Everybody good? Okay. Okay, let's go back to the same problem. So it saves me a little bit of time. So the scores on your chi-squared free response test were normally distributed, same mean, same standard deviation. What score is at the 75th percentile? This is exactly like the last question. So we would go back to normal CDF. I mean, second vars, inverse norm, number 3. And now I want the 75th percentile. So you can see how these are. And basically that means that this score, 75% of the scores are below it. So you'd have to have an 89.34. Okay. Okay, so if Jacob scored in the top 20th percentile, what was his score? So here's what we know about Jacob. He was in the top 20%. So his score was here, and there's only 20% above him, which means 80% are below. We always need the area to the left. We can never use the area to the right. Actually, Brandy, your calculator can go to the other side, can't it? And remember you showed me, but in my calculator, I don't think I can. So I'm stuck with always knowing the area to the left of that number, never the right. So we're going to go back. And we're going to say second vars. Should I do normal CDF or should I do inverse norm? I'm looking for this number.
Inverse norm.
All right, let's try an inverse norm. Yep, that's exactly what we're doing. So I'm going to do inverse norm, 0.8, same information. Okay, so his score would have to be, would be a 90.24 if he was in the top 20 percentile. Okay, I know these are really repetitive and really that's not a whole lot to the normal distributions that I'm going to do with you guys today. All right, so if they ask you what is the 50th percent middle score, so let me see how I actually said that. So now my mean is 89 and my standard deviation is 3.1 and I want 50% of the middle scores. So I know I need the 25th percentile and the 75th percentile, and whatever those two numbers are, they will tell me where 50% of the middle scores are, and then 25% will be lower than this number and 25% will be higher than this number. So it's just two inverse norms. So I use the percentile, the mean, the standard deviation, and I got a 91.1, so that number would go here. And then I did another inverse norm using 25, and I got an 86.9, so that would go here. Okay. Everybody good? Any questions? Okay. Remember in normal distributions, the z-scores are important too. So if I know that they're normally distributed with the same standard deviation and mean that, well, I'm not sure that's the same mean, but a different standard deviation. What is the standardized score for a test grade of 91? So remember your z-score formula is x minus mean over standard deviation. X is the value we're testing. We're testing the 91. And the mean is 85.7 and the standard deviation is 2.85. So if I'm testing those values and I want a z-score, well, first of all, should it be positive or negative? If I'm testing the number 91 and my mean is 85, should I have a positive z-score or a negative z-score? Anybody? Think about where it is on the curve. You got the curve. Your mean is 85.7. And the score I'm testing is a 91. So what kind of z-score will it be, positive or negative? Positive. Okay, I gotcha. It's going to be positive. So I did the numbers, 91 minus 85.7 over 285, and I got a 1.86. So when you want to find the z-score, you need to know the test value, the mean, and the standard deviation. Everybody good? Morgan, are you good? Brandy? Okay. And this is another one. So again, we're testing 78, and we know that its z-score is negative. And now we're saying, what is the standard deviation? So in this case, I put the z-score in, the test value and the mean, and to find Sx, I'm just going to switch these two around. I'm going to multiply by S sub x and divide by negative 2.7. And so I actually get a standard deviation of 285. Basic algebra 2. Once you know what the formula is, you put the numbers in and you find it using algebra 2. I'm going to skip that one. We're getting really close to the end here. Okay, so Ms. Y says that her students will score an average of 85 on all of my tests this year. So if the mean is actually 83 with this standard deviation, what is the probability that her students' test averages will be less than 85? So if the mean is actually 83 and we have 85 is what I'm guessing, the probability is the area to the left. So you're just going to go into your second vars, normal CDF. You're going to leave this as negative 9999. I'm going to say 85 for the upper. My mean is 83, and my standard deviation is 4.5. So that probability is 67.16% or 0.6716 if you don't make it a percent. Okay, so what is the probability that my students score between 64 and 84? So now I have the upper and lower bound, so I don't need to use an infinity. I can go to 64 and 84, so I can go back into the calculator and put this as a 64 and this is an 84. So about 58.8% will score between those two. And of course, above 90, you would just put 90 in for the lower bound and lots of 9s for the upper bound, and then you would run that probability. Any questions so far? Okay. Okay, so remember we did what we called transforming the data. So let's say that I took your scores and I added 10 points to everything. So the mean of the original test was 85.7 and the standard deviation was 5.4. What is going to happen to the mean and the standard deviation if everybody gets 10 points on their test? What is the mean going to be?
Won't the mean stay the same? Or is it the median that stays the same?
Yeah, which one stays the same? You're absolutely right. One stays the same and one changes.
Oh, I think it's the standard deviation that doesn't change.
Right, because every score shifts, so the spread is still the same. So the mean will go up by 10 points. So the mean will go from 85.7 to 95.7, but the standard deviation is going to be the same. It's still going to be 5.4. Okay, but now let's say I added 2.5% to everybody's test by multiplying everybody's score by 1.025. Now what happens to the mean and the standard deviation? Now we're multiplying, not adding.
Are they both changing?
Absolutely, they both change. Both of them go up by this number because when you multiply, it also spreads out the scores and it will move the mean up as well. Well done, Jacob. You have an intuitive sense for this. Anybody else have questions on that, or are we good? Have to move your faces, okay? And that's actually it. I wasn't going to go over these. No, that's it. So let me go back. I'm going to have you guys do the, let me see if I can find, this is always in the way. So when I go into my AP, mine looks different from yours. And then it never likes my password. So, and by the way, I don't think only a couple people did the last one. So there should be, I need to go to classroom. I need to go to, so you're looking for the one called normal distribution. And I think it is only, let me see if I've assigned it. Yeah, I've got one called normal distribution homework. Oh, and it's 13 questions. So the describing data, 2 of you have done it. 3, I think, are in the middle of it. 8 of you haven't started it. And then this one is all brand new, but this one's only 13. This one's only, no, it's not 13 questions. How many questions is it? I'm not sure. It's much, much shorter. So you will need a calculator. You can either use Desmos or you can use your graphing calculators. But then in addition to that, I want you to go back and do the quizzes that I'm going to post the quizzes code. I think it's 594282. And that's all. Just the questions. Nope, that's the wrong one. No, that's the right one. It's just not 50 questions. It's less. So do the questions and the quizzes and you should be done for today. So that's all I've got for you guys. Does anybody have any questions? No? All right. Something about the test. Oh, there's some interesting stuff coming out about the test, which I'll share with you guys a little bit later down the road, but I wanted you guys to have an easy day today. So if that's all you have, that's all I've got. We can say goodbye.
Bye.
Bye,
Bye,
everybody.
Michelle Umbrella.
See you guys again.